Graded Science. This is Mr. P. We are going to wrap up section 3 today, the more of the inner solar system. So we talked about Mercury and Venus in our last video, and now we're going to talk about the next one being Earth, because this is again, the third planet away from the Sun. And Earth, which we should all be familiar with, has a suitable atmosphere and temperature range for water to exist as a liquid. So this liquid water right here has been basically one of the most defining features of why life was able to thrive. Again, the temperature, the atmosphere, kind of all the perfect storm, our distance from the sun, all the perfect storm for us to survive here on this planet. Again, Earth is unique in several important respects, and the presence of liquid water makes it possible for Earth to support millions of different species of living things. And then water also causes erosions, which has shaped Earth's land surfaces in many ways. Again, water, the big driving force behind it. Again, we're going to talk about how Mars may have had water at some point, or actually probably did have water at some point. Again, there's ice on some places, but the liquid water on Earth, again, is huge for the survival and thriving of life as well. Again, Earth is unique among the planets. Again, we're 70 some odd percent liquid water covering our surfaces. Again, very unique to us. Again, allows us to have life to exist. And unlike most smaller planets and moons, we have enough gravity to hold most of our gas molecules, which allows us to maintain a thick atmosphere. Again, not too thick as to crush us, but just thick enough to kind of keep as many bad things out and good things in, and to maintain a suitable temperature range for us to survive. And then the gases that make up our atmosphere, it's not composed mostly of carbon dioxide like the atmospheres of Venus and Mars, because some living things use carbon dioxide and produce oxygen. At one point, Earth did have some pretty hostile gases in our atmosphere. Again, some of the emergence of some autotrophs, some plants and things like that started using up the carbon dioxide and pumping out oxygen, kind of helped change the composition of our atmosphere as well. The Moon, Mercury, and Mars are so small that over time they have lost much of their internal heat and they have become geologically dead. Earth, however, this is again another big thing with our plate tectonics, with our mantle convection, which again I know we kind of skipped over those units this year, but you've talked about them a lot in past science classes. Earth is in fact large enough that it has not had a chance to cool down much, so Earth has moving tectonic plates that continually change its surface. Again, those moving tectonic plates allow some of the heat from the internal Earth to be kind of reach the surface, and to allow, again, volcanic eruptions, again, altering the surface, and again, very important for gravity. There's just so many things that tectonic plates do, and that the fact that our core is still active that allows Earth to survive. So again, kind of went through Earth pretty quickly. Again, we know a lot about Earth. We might not know as much about the other planets. So now we're going to move on to Mars, and Mars is kind of just one that a lot of science fiction bases kind of on some of the possibilities of what could go on Mars. Because, again, one reason why we care so much about it is because it did show evidence of once having a great deal of liquid surface water. Again, there's not currently liquid surface water, but it did at one point probably have some. And then also, Mars is the most Earth-like of all the planets. Again, if we're moving away from the Sun, it's the fourth planet from the Sun. The weathering of the iron-rich rocks on its surface give the planet a reddish color. So again, Mars is always called the red planet, again, because its rocks have a lot of iron in them. Though the surface of Mars is very old, as shown by the presence of many impact craters, it once had many volcanic eruptions. So at one point in time, Mars was very active, but however, its core cooled down much quicker than Earth. So now it's kind of what we call, again, going back there, a geologically dead planet, because its core is no longer producing all that heat that our core is producing and causing all that convection currents. The atmosphere on Mars is very thin. Again, it does have one, but it is extremely thin, so we can see the surface of it with a telescope. Again, and its distance from the Sun makes the surface very cold, and in conjunction with their thin atmosphere, make the surface very cold. Again, they range from negative 140 degrees Celsius to 20 degrees Celsius. So again, it's a little bit less extreme, but again, negative 140 degrees Celsius, still unbearably cold. Again, to 20 degrees Celsius, more of an Earth-like temperature there. Mars' atmosphere is more than 95% carbon dioxide. Again, it's similar to in composition to the gases that make it up to the atmosphere of Venus, but is in fact it's much thinner. Again, the pressure is not going to be nearly as great as it is on Venus. Again, uh, much thinner atmosphere there. And then the water on Mars, which again, that's kind of why we care so much about Mars and why Mars receives so much attention. There is currently no liquid water on Mars surfaces right now, but there likely, excuse me, was some in the past. Some geologists think Mars' northern lowlands were once covered actually by an ocean, so they not just a little bit of water. There actually was a great deal, they believe to be a great deal of water on Mars. Um, some water vapor has escaped into space. Some is stored in ice caps at the poles, and there is actually some frozen underground just below the surface. So there is water there, just not in the liquid state. It is frozen. So there's a good deal of ice on Mars. Um, because it had water on its surface in the past, many scientists wonder, again, wonder being the big word there, if life once existed there. Um, there have been robotic probes that have carried out experiments on the Martian surface to look for signs of life. However, no one has found clear evidence that there has ever existed life on Mars. And when we say life on Mars, we're not talking about green aliens flying little circular UFOs. Most likely they're looking for something very similar to maybe a bacteria or something like that that we have here on Earth. Again, it would be very simple life that we're looking for. Again, we're not looking for giant alien colonizations because if that existed on Mars, I think we would probably know about it by now. Again, that's what the life they're talking about looking for. Again, probably small bacterial things like that. Here's a picture of an ice cap on one of Mars' on the north pole of Mars there. So it does have ice at both poles. The largest volcano in our solar system is actually present on Mars to show that it was once a geologically active planet. It's called Olympus Mons. So that is the largest volcano. So that'd probably be something important. Yeah, you need to know the name of the largest volcano in our solar system. And these Martian valleys are thought to have been formed at least in part by large flows of liquid water. Again, erosion on the surface had to be caused somehow. They believe that liquid water caused that, again, similar to how our Grand Canyon would have been formed. And then, also like Earth, Mars has distinct seasons. Mars seasons are caused by the tilt of its axis. Over the course of a Martian year, their ice caps grow and shrink. So, again, kind of with the changing fluctuation of the temperature. And then the changes in the seasons can also cause excuse me, cause large dust storms that can occasionally rage across the entire surface. So Mars does have some things going on there with its different seasons. Again, the ice kind of growing and shrinking, but again, it's still what we call a geologically dead planet because its core has been cooled, but there still is some activity going on there. And this is a photo of some of the boulders that exist on Mars, again taken by the Mars Exploration Rover Spirit in 2006. Again, Spirit found rocks and minerals that were formed or were altered by water at one point in time. So we do have conclusive evidence that water did in fact exist on Mars at one point. Again, it's not there now. So the last kind of thing to wrap up our inner solar system are asteroids. So an asteroid is now scientists believe that they're remnants of early solar system that never came together to form a planet. So they're beyond Mars, again, kind of leaving the inner solar system. There's these rocky bodies called asteroids that can be found orbiting the sun, and this region is referred to as the asteroid belt. Although most although most asteroids are in fact found in this asteroid belt, there's others that orbit near Jupiter or range throughout the inner solar system. So there's these rocky bodies kind of floating around orbiting the sun, again called the asteroid belt. Astronomers have discovered more than 10,000 different asteroids, and many more are thought to exist. And the reason why is because most are extremely small. Again, if you think about it, again, less than 1 kilometer in diameter. There are only 3 that are larger than 500 kilometers across, so there are 3 rather large ones orbiting in this belt. But for the most part, most of them are very small. Again, when you talk about space, things being in space, again, most of them are less than 1 kilometer in diameter. There are some large asteroids that have enough gravity to have pulled themselves into a nearly spherical or oval shapes while forming. So they kind of generate enough, get enough size, they kind of pull some things to them that they kind of take the shape of the revolution, the elliptical plane that they make. They kind of have an oval shape because of that. Again, they're strong enough gravity. However, smaller asteroids don't really have that gravitational pull, so they kind of keep an irregular form. And scientists think that some asteroids are just like floating rubble heaps. They're held together by weak gravity. Again, there might be some asteroids, again, that are always next to one another because there might be a weak gravitational pull that's kind of keeping them near one another. And here's a couple pictures of some of the larger asteroids. The letter A there is asteroid Ida. Again, the photographed by the Galileo probe on its way to Jupiter. And then in 2001, the Near Shoemaker space probe actually landed on that asteroid called Eros, I believe is how we pronounce that one. So those are a couple of the larger asteroids that kind of make up the asteroid belt. And in the past, scientists thought that asteroids were the remnants of a shattered planet. They thought that, again, something happened to cause a planet to be destroyed, and then it kind of, because again, it's still orbiting, it's still there. However, they just now believe that they're just the remnants of the early solar system that never came together to form a planet. And the reason why they believe that is because there's just not enough mass there in the asteroid belt. If you put together all of the asteroids into one big mass, they would form a planetary body with only about 1,500 kilometers in diameter, and that's not really that big. So that kind of just goes to support the fact that asteroids, again, they were chunks that were floating around when our solar system was first being formed. Again, they weren't big enough to form a planet, but they did kind of get pulled in by the gravity, and that's how they formed their kind of their orbit there. So that is it for section 3. Let me know if you have any questions.